If you ask most people how Amazon makes its money, the answer seems obvious: selling products. After all, Amazon looks like the ultimate online store. Basically, anything you can buy, whether it's digital or physical, Amazon has it. But the strange part is this: selling all of that isn't where Amazon really makes its money. Behind the shopping carts and delivery trucks, there's another part of the company doing something completely different. Instead of shipping boxes, it rents out computing power, data storage, and the digital infrastructure that thousands of other companies rely on to run their businesses. In 2025, that division, Amazon Web Services, generated about $45.6 billion in operating income. That's out of roughly $80 billion for the entire company. In other words, more than half of Amazon's profits weren't coming from selling products, they were coming from servers, which raises a strange question. How did a company that started as an online bookstore end up quietly becoming the company that runs much of the internet? By the early 2000s, Amazon had grown into an incredibly complex operation. Customers were visiting the site in massive numbers, independent sellers were listing products through the marketplace, warehouses were constantly receiving shipments, sorting inventory, and sending packages back out across the country. Behind the scenes, an enormous collection of software systems was coordinating all of it. Some systems tracked inventory moving between fulfillment centers, others managed product listings and recommendations, with separate services handling payments, customer accounts, order processing, and delivery routing. As the company expanded, more and more engineering teams were building new tools to help keep the operation running. But those tools weren't always designed to work together cleanly. In many cases, engineers simply connected their systems directly to another team's database. If one service needed information, it would just reach into another system and retrieve it. At a smaller scale, that kind of shortcut was manageable, but as Amazon grew larger, the shortcuts began creating serious problems. Changing one system could unexpectedly break another. Engineers had difficulty understanding how different pieces of the platform interacted, and deploying new features became slower and riskier because almost any modification could ripple unpredictably across the company's system. For a business whose entire operation depended on software, that kind of fragility was dangerous. So Amazon imposed a radical rule across its engineering teams. Every internal system had to expose its capabilities through standardized rules known as Application Programming Interfaces, or in other words, APIs. From that point forward, teams were no longer allowed to access each other's databases directly. If one system needed information from another, it had to request it through an API. This forced Amazon to reorganize itself. Instead of one big interconnected system, the company gradually turned its software into hundreds of smaller services that communicated with each other in a consistent way. At first, this shift solved an internal engineering problem, but over time, it created something else entirely. Once Amazon's internal systems were separated into independent services, those services no longer needed to exist inside of Amazon. They could theoretically be used by other companies as well. Amazon had already done something similar once before. A few years earlier, it had opened its retail platform to outside sellers through the marketplace. Now, the company was beginning to consider opening its computing infrastructure as well. In 2006, that idea became a real product. Amazon introduced a new service called Amazon Web Services, or AWS. Rather than building expensive server rooms of their own, companies could now simply rent computing power from Amazon's data centers. This new model became known as cloud computing. Their first service was called S3, which allowed developers to store huge amounts of data in Amazon's data centers. Soon after, Amazon released EC2, which allowed software to run on virtual machines hosted inside those same facilities. To many engineers, this solved a frustrating problem that had existed for years. Before cloud computing, launching a website or online service required buying hardware long before it was actually needed. Servers had to be installed in specialized facilities and maintained by technical staff even when traffic was low. If a new product suddenly became popular and attracted millions of users, the company might not have enough hardware to handle the demand. But if traffic stayed small, those expensive machines would sit idle. AWS changed everything. Instead of purchasing infrastructure, companies could now simply rent it. If demand suddenly increased, they could instantly scale up their computing capacity. If traffic dropped, they could scale back down and stop paying for resources they no longer needed. Computing power had effectively become a utility, and once that option existed, developers adopted it quickly. Startups began launching entire companies on AWS without needing to build their own data centers. Large tech companies migrated parts of their infrastructure into Amazon's cloud, and everything from streaming platforms, mobile apps, and enterprise software increasingly relied on the same networks of Amazon servers. Gradually, the company that had built infrastructure to run its own retail platform was now providing that infrastructure to the rest of the internet. As AWS expanded, Amazon began constructing enormous networks of data centers around the world. Inside these facilities, thousands of servers operate together to process data, store information, and run the applications modern businesses depend on. Cloud computing was only one part of a much larger system Amazon was building. While AWS powered software, the company continued expanding the physical components that moved products through its retail platform. Its logistics network grew into a complex global operation supported by cargo aircraft, regional sorting hubs, and thousands of small delivery companies operating Amazon-branded vans. Inside the company's warehouses, robotic systems began transforming how goods were handled. Mobile robots could move entire shelves of products across automated floors, reducing the distance human workers needed to walk. And new robotic arms capable of identifying and sorting individual items started assisting with packaging and distribution. At the same time as this was happening, Amazon was also quietly building another major business inside its marketplace: advertising. Brands realized that appearing at the top of Amazon's search results placed their products directly in front of customers who were already looking to buy something. This allowed Amazon to build a high-margin advertising platform that generates tens of billions of dollars in revenue each year. Amazon also began investing heavily in another emerging technology: artificial intelligence. Through AWS, it was able to develop specialized chips designed to train artificial intelligence models more efficiently, allowing companies to build advanced machine learning systems at scale. New platforms such as Amazon Bedrock for building AI applications and AI assistants like Rufus, which can help shoppers in the Amazon store, were all introduced to explore how these capabilities could be integrated into the broader Amazon ecosystem. And in space, Amazon launched one of its most ambitious projects yet: a satellite internet network called Amazon Leo, designed to deploy thousands of satellites in orbit and provide global broadband activity to unserved and underserved communities. One thing is clear: Amazon isn't slowing down. Rather, it's expanding deeper and wider than ever before. So over the past few decades, Amazon has been building something far larger than a store. Businesses now rely on its marketplace to reach customers, its logistics systems move products, and its cloud infrastructure runs software all across the internet. Increasingly, they also depend on Amazon's technology to train artificial intelligence models and potentially to deliver internet connectivity from orbit. At first glance, these systems appear to belong to completely different industries: cloud computing, logistics, advertising, artificial intelligence, and even satellite internet. But they all follow the same underlying pattern. Amazon builds large-scale infrastructure and then allows other organizations to plug into those systems. So what began as a simple online store has gradually evolved into a collection of interconnected systems that literally millions of companies rely on to operate. Amazon is no longer participating in markets. Increasingly, it is shaping the systems those markets run on. And this raises a deeper set of questions about the future. Will businesses compete with Amazon, depend on Amazon, or even both at the same time? If more of the internet runs on infrastructure owned by only a few companies, how resilient is that system? And when a single company becomes the backbone of both commerce and computing, who regulates the backbone? Above all, the real question may no longer even be whether Amazon is a retailer. Instead, it's what kind of system is Amazon becoming?